Hi students, welcome to Preliminary Chemistry and the Metal video series. This is number 10 and we're going to look a little bit more detail at ionization energy. So in the previous video we were starting to look at the position of metals in the periodic table in relation to their reactivity, and we said one of the key factors that helps us to predict the reactivity of metals is the first ionization energy. So in this video, we're going to first of all define the first ionization energy, which is the measure of the amount of energy needed to remove one electron from a neutral atom in its gaseous state. Now this is relating to the first ionization energy. There are subsequent ionization energies which we'll look at later on, but of course only that first one will be from a neutral atom. Every electron that is removed subsequent is actually becoming it's coming from a charged atom, and therefore A, it's more difficult, and B, it's going to continue to increase the size of that charge as subsequent electrons are removed. As we mentioned in the previous video, the lower the first ionization energy, the easier it is to remove the electron, and hence the more reactive the metal. So these are the things to keep in mind as we go through this video. Now, the thing that I mentioned in the last slide is that the electrons can be removed sequentially according to the strength of the force that binds them to the nucleus. So the link between the electron, which we know is a negatively charged particle, and the nucleus, which is a source of positive charge, there is an electrostatic attraction between each electron and the nucleus, and that force must be overcome in order for us to remove the electron completely from the influence of the atom. It's the same way as if we move objects away from their gravitational field here on Earth, they will be attracted back to that center of gravity, and we have to put a really large amount of energy in if we want to actually move them completely away from the Earth's gravitational field. The important thing to remember, of course, is that we can discuss things like successive ionization energies. So I1 would be removing the first electron, and then I2 would be removing the second electron, and so on. The important thing about removing the second electron is that when you're removing the second electron, you're removing an electron from an already charged particle, so a cation. So the element itself is neutral. When you remove an electron, it becomes positively charged, and so then we're trying to remove subsequent electrons from that positively charged ion, and so we would expect their ionization energies to increase. The lowest ionization energy for any element is always its first. One important thing when we're looking at our ionization equations is we need to make sure that they are in the gaseous state, so that's one of the important things, and so then you'll see this little symbol G to indicate gas as we look at some of the examples of ionization energies. So the first ionization energy we can represent as the neutral element losing an electron in order to become a cation, okay, a positively charged ion. Notice that the subsequent ones, ionization energies, are removing more and more electrons, are actually being removed from ions. So they are already cations now, they're just becoming higher and higher in their charge. And you can see as we go down this list, first to second to third ionization energies, we're removing these electrons subsequently from the atom. Now, something else which is important to consider at this point in time is that we can see some quite significant changes in patterns of ionization energy as we go through the shells. So if we pick something like sodium, 281, so the first ionization energy would be removing this electron from here. The second ionization energy would be removing one from the next shell down. So we've got an additional situation occurring here. It's not just that the sodium becomes a sodium ion and therefore has now more protons than electrons, but also we've actually changed shell. We've moved from removing electrons from the third shell to the second shell. And we notice that often there will be a big increase in the patterns associated with successive ionization energies when we're moving from one shell to another. We can also compare the reactivities on the basis of these first ionization energies for different metals. So here is sodium. Its first ionization energy is 502 kilojoules per mole, and this term is one that we'll look at in the next couple of videos. Magnesium is the element that's next to it. So sodium is element number 11 and magnesium is element number 12. So as we go along that period, what we find is the ionization energy is slightly higher for that first electron. So which means we've got 11 protons in the nucleus here and 12 protons in the nucleus here. So we would expect a slightly higher force of attraction. And this higher electrostatic force results in a higher first electron energy. But the comparison between sodium and potassium is interesting because potassium is in the third period, the fourth period. And as a consequence of that, you can see its first ionization energy is lower. And that's because potassium has an electron configuration of 2881, which is potassium, whereas sodium has 281. So we're still removing this outer shell electron in each case for the first ionization energy, but because for potassium it's coming from the fourth shell, or the fourth energy level, it is easier to remove because it's further away from the nucleus. The factors that affect electron removal then are the size of the nuclear charge. So obviously if we were to remove something that had a higher charge than an electron, that would affect it. The distance of the electron from the nucleus, and we saw that in the difference between sodium and potassium, and also the presence of shielding inner electrons. And this is something that we'll look at in class in a little bit more detail. Those shielding inner electrons are acting between the electron we're trying to remove and the positive nucleus, and that also has an effect on the ionization energies. Thanks for watching.